All right, here's another one. This problem right here is going to be something that you are really going to have to do on your final. And we're going to have to reach back into thinking about all of those different theorems that we learned and different ways that we can prove congruency or the relationships between angles. In case you don't remember making it, even though we talked about it on Friday, make sure you find your angle relationships flip book. Obviously, this isn't my flip book. This is just a copy of the one. You need to have yours for the final. All right, back to this. We are going to check this little beautiful set of lines, and then we're going to figure out the angle measures for all of these angles on here and fill it in this little table. We also see over here that segment AC is parallel to segment EF. What I didn't write on here is that segment or line BD is the transversal that goes through. So that will give us a little bit of information as we go through. We also see down here, angle BGC is 65 degrees. It's given. So looking at that, we can look at angle X. There are a couple different ways that you can do this, but the way I'm going to do or solve this is just say that 65 degrees plus X is going to be a linear pair. Remember that a linear pair is equal to 180. So I'm just going to go 65 degrees plus X degrees equals 180 degrees. Minus 65, minus 65. We're left with X equals 115 degrees. 115 degrees down here. How do I know? Oops, sorry guys, that's my hand falling asleep and dropping the pen. Is the way that I know this, like I said, is it's a linear pair. All right, got X done. Now, next one is Y. X and Y. Well, these X and Y are what we call vertical angles. So, and remember, vertical angles are always congruent. So I know that angle Y is going to be 115 degrees because of vertical angles. Now Z. I'm going to go ahead and use the vertical angle again with 65 degrees. So 65 degrees and Z are the same. They're in the same spot. They're vertical angles. It's going to be Z is equal to 65 degrees because of vertical angles. Now I'm going to go ahead and scoot down here to P. So there, again, a couple different ways that we can look at this. I notice that P is in the same spot as X was. So they are what is called corresponding angles, which means P is congruent to X, or angle P is congruent to angle X because of corresponding angles, which means angle P is also 65 degrees. Corresponding angles. So R, I'm going to we're going to also use the corresponding angles for R and see that over here, oops, guys, I made a mistake. P is not 65 degrees. P is 115 degrees. I looked at the wrong spot. Hopefully you all caught that. PX is 115 degrees. So P has to be 115 degrees. Sorry about that, folks. So we're going to put the little double lines on here so that I remember which ones go with which. Sorry. So R is corresponding with 65 degrees. So that is 65 degrees. Again, the corresponding angles. See, guys, even teachers make mistakes, and it's okay. That's why you check your work again. All right, so now what we want to look at, we're going down here to the S and the L. When we do that, we can use, for angle S, we can use vertical angles again. So it'll be 65 degrees because the vertical angles, they are congruent. And then over here, L is a vertical angle with P. So it is 115 degrees. And there are many other ways that we could also do it. We can use the, if we had wanted to do, instead of corresponding angles with angle X and P, we could have done alternate interior angles. We could have done it the opposite way too. Just remember to really be using your angle relationships book when you have a problem like this, so that you don't have to do a ton of math every single angle measure. All right, I will be around if you have any questions. Good luck.